left our design after we had imported our CAD file.
Yes.
Our previous lesson ended after I had imported this file here you are seeing on my screen. So we were supposed to start, we were supposed to add wall loads on this beam in Protostructure. Thereafter, we were supposed to add, I think, slab, and then we proceed to do analysis. So,
correct.
So that was yesterday. In today's lesson, I was preferably intending to just go further with the Protostructure. I load my model with I assign loads to my model, and then I do the analysis, and then I'll be able to produce these structural detailing like the one you're seeing on my screen. So this is what we want to do today. We see if we'll manage. We open our model like this. You can go to the option. We can come to this option here, which is external reference drawing.
Okay.
Load project. Then we have our file here. So the design is in millimeter. So under unit, you just click on millimeter. Otherwise, you'll have chosen either centimeter or meters. Just click OK.
Okay.
Give it some time. So you can say use colors, yes. And then you increase the intensity to maximum so that you can be able to see your color. So you can already see it has traced up here. Then now you import members, and you remember that the members were the grid line that we created as axis and the one that were for the column. So if I may just reopen my CAD file, you can see there were layers that were created here. One of it was the grid. Yeah, there was, we can check them from here. So we have layers here for this structure. The issue is that I haven't opened the right file. This is the right file. Huh? So if I come here under the layer, I can get the grid and the column. So these two layers must be created in the AutoCAD general arrangement drawing, so that now once you come in Protostructure, while we are importing the two grids, the first grid lines can be imported as grid line here, and then the columns can be imported as the column grid lines that had been created. From here, you can simply click OK. And then you can check to see if there is any overlapping or clash of this either B or either axis, and you can see that there is zero error. So this will check on column overlapping, proximity, validity, all these one are okay. So you just cancel okay because there is no error. So we can do that. And then now we also cancel these. So on our screen, you can see now we have imported all our columns. To check this one in 3D, you can come to Story. Under Story, there is just above the Story one, there is View. Right click, check on 3D. Yeah, you can check. There it is. So once you import, the immediate step is to create our beam. So Prota is a straightforward software. So you just go to plan view. You can click on views and then you go back to your plan view. On this ribbon option here, on this tab, we have our column, we have our wall, we have our beam, slab. These are the most common tabs that are used our button, so to speak. So for now we are using beam, but very soon we'll be using the slab and maybe the wall. So once you click on beam, you define your beam based on the column size. So if you want our beam to flush exactly with this height of the column, we remember that our column dimension, so you can check maybe if you have, if you're not sure with the distance of this, you can just click there and then you can check these are around 200. The lower one was 300. So this was a column of 300 by 200. So our beam should be, sorry, undo. So our beam should be, breadth is the dimension. So our beam should be 200 by the breadth, the depth of the beam can check as the minimum, the minimum depth that is required, which is 450, or you can go to 300, but let us just take 450 for this case, because we are seeing that the span or the breadth is too small, so we tend to increase the depth to a minimum of 450 or above. So you can click update. So you have already our beam, so you can just insert our beam like this. So just think. So this software automatically divides these beams according to the columns that are available along this continuous beam that I'm creating here. So just to save time. So these are all our vertical, our horizontal beams.
Okay.
So once you are done with that, but remember also we have a slab. Our column here is not vertically arranged, but I just assumed it's this type, the one for the staircase, but there is no problem with that. So sometimes you find that a column hasn't flushed with the wall. So what you do, so you can select this column, then right click, go to properties of the column, and then under this one you can come and say you want it to flush at the center line, or you remove the something called eccentricity of this column. This is 0, 0. Or you can simply rotate it, rotate column, then go back to properties. I want it to be at the center. So just the E means eccentric. So you want it to be vertically along the vertical axis. So you just remove this eccentricity to 0, eccentricity 1. That's along the x-axis, and eccentricity 2. That's along the y-axis to 0. And then just click update. You find that our column now is at the center of this wall, because all these were being based on the wall. So let me also just rotate this one and change it. So I can right click, say rotate column to vertical, and then again right click, go to properties, change the eccentricity to 0. 0 both E1 and E2, and then update. Then you have it there. So let's continue creating our beam. So you can just simply right click on this beam, and then check on properties or click on properties, and then you have activated your beam. Then now create your beam that it's running just from X6 all the way to, we have beams below here, yes. So we are done. Let's also create this other beam here. So there is a beam that I've left here. Yeah, with that design can just work. So once I add my beams, the next thing that I'd recommend to be done is to define your beam end conditions. So defining our beam end conditions, we can just select a multiple of them and then we assign. So for instance here, we can select the beams that are not hinged on both sides, like this one. We have this, we have this. So their end conditions are same, all this beam. And then you can also come here and select on this. Let's just finish with the horizontal ones first. Right click, come to update end condition, no hinge, and then just say apply to the selected. So if you look here, there is some blue line and some two red dots. So you have already defined those one. Then you can come
So
to
what does
the,
that mean now? Will it act like it's fixed?
yes,
Fixed
it,
at
it,
the edges?
yes, it's fixed at the edges.
Okay. Okay.
So this one is just to help the bending moment diagram so that the software can tell where we have the maximum compression and tension forces. And also it will help in saving on reinforcement. And then you can come on this one, not this one, but if I click on this beam here, I click also on this, I click on this, I click on this. This one, they are hinged on the left. So you can click that, apply, and we are done. And then just come on this one. You can start with this. Click on that, click on this, click, then right click, say they are update end condition hinged at the right. I think this one you can right click, just do that correction I've just noted, and then you just say both are. So I think we are done with the horizontal beams, so we can look at the vertical beams. So for the vertical beams, which are this one, so if I check on this one, so this one, they are hinged towards the right. Either if they are not fixed or if they are hinged on the right side, so you will choose hinge at the right. At the right also can represent the upper side, and then at the left can represent the lower side. So all those beams that are hinged on the upper side include this one, this one. This one is discontinued towards the upper side. Also this one. Is there any other? No other, just those ones.
Okay.
So that is the upper side. Select. Yes, and then we come to the one that are hinged on the left. So we have this one, we have this, we have also this, that one. But why did we add a column on this side here? Was it necessary?
No, no, not really.
And when we are designing, we should just check and just to check whether this distance is around 4. So it's not, we don't need a column there. We don't need this column. Let us just delete it. So we can do this. So I want to create just a single beam because the other one was appearing as if it was disconnected. So end condition. So this one is to the left. Apply. Then just come and pick the one at the centers. Control, just press Control and select all these ones that are fixed. We have any other? Yes, we have this one. We also have this one. Any other?
Hinged to the left.
No, these one are fixed because
Okay.
they are falling in between. They are continuously.
Yes, yes, yes.
Our next step will be adding our slabs. And I was just trying to look at this design. I was thinking
Okay.
of we have a balcony somewhere. Let me also come back to architectural design. See, if we zoom, we have a balcony here. However,
Yes,
at the ground level, we were having just one single room.
yes.
So I was just thinking that, is this a balcony? Should we use a cantilever or how will we design this? I was just thinking that we should bring these columns at these and then we just introduce a cantilever below on this side. So that was my,
So that would mean
we are designing, this is the upper floor, isn't it? Huh? The floor,
there's a wall.
the
Yes.
slab, yeah. So if you look in, so I was thinking that you could introduce a cantilever here. Or should I just,
I think it's better we leave it that way
yes,
because there's a wall beneath. Can we leave a wall hanging? Let's say we have a wall somewhere in the middle. Sorry, a column somewhere in the middle, and then now the wall extends up to the end. Can that work without? Usually at the end of the wall, there should be a column, right? It's not necessary.
no, the cantilever can still support that. Huh? The
Okay.
walls, they will be transmitting the, let me just put this thing in 3D. Let me convert it into, I think we were having some way of, so below this room, below this panel, this one, below it will be a room, but on top of it, half
Yes.
of this room will be,
Yes.
let's confirm from the designer, the architect. So there will be a bedroom and then a balcony.
All right.
And there is a wall. So I was just thinking that I could design this one as a cantilever, or we can just,
Okay.
because now
Yes. Cantilever is okay. You can do cantilever.
we can do cantilever.
Yes.
So if we are just doing a cantilever, it's designing it. So we just take the measurements from the AutoCAD file.
Okay.
the AutoCAD file, you just look at the center of this wall. You can see, because we have grids here, we didn't generate a grid here, but you want, so we can right click, copy, and then so this around 1600. So you just measure, you make sure that you understand the distance between the edge of this slab and to the edge
Yes.
of the cantilever, and also the 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 distance between the center of this wall to the edge of the cantilever. So those are the two distances that I wanted us to note, but we can just approximate. So you'll
Okay.
allow us just to approximate so that we can move on. So you will come on this axis, right click, just say offset, and then you can press Shift F2,
Yes.
and then you can write 2000. Let's just use a just arbitrary figure. So let's assume that's the center, and then we can also come up to there. You can just say another 2000 just to make it not complicated in any way. So Shift F2, write 2000. Yes, let's assume that this is a bit too. So we can just now get the column here. Right click, draw this column there, then draw the column. Then now let's just remove this beam here, or we can move this beam. Copy, no, properties. Define end conditions. We say this is both end are hinged.
Both ends are hinged or not hinged.
Both ends are hinged. That's what I, because no,
Yes.
there is, it's not continuous on the other side. So the one which you can say like are not hinged like this beam here. So I think that's not bad. So I did this to allow me make this one be a cantilever. So I can just remove these columns here. So just delete them. So let's come to a slab. Under slab, you come to, because we want to start the cantilever, we go to the option here, not that one. We come to type of the slab we want to do. We do type 12, which is that of a cantilever. Now having a type 12, we decide the height of our cantilever, which is 150, which will be the same as the height of the slab. And then L is the length between from here to the end, from the edge of this beam, from the edge of the outer beam here to the end of or to this axis or to this grid line here. So let's get this, I don't know if you can be able to measure it exactly. Something to do with I think 1540 will just be fine. So if we come to our slab, so that's the distance which we will put there. So we have our slab use type 12. So our length here will be 1540, and then our height will be 150, and then our loadings will be, you have self weight, and then you have dead load can be 1.5, imposed load can be also be 1.5, and then parapet weight, now it's the weight of the, okay, in most cases we use railings, but sometimes we can also use the masonry wall, some dwarf wall on these cantilever. So if you work out the unit area, the unit weight, and then you multiply by the surface area, in most cases you find that it will come to 9.8 to 10.8 kilonewton per meter square or per square meter. So that you have to add this unit here. Now that you have,
Okay.
if you omit this parapet load, it will not show.
Yes.
It will not show. So let's just get there. But I'll send you the evidence where how to arrive at it, or where it has been indicated on that design code or design manual. So
Okay. I
updates.
think also for the imposed load
Yes.
of a balcony, it's usually different. It has a different figure. If you right click that imposed load part, it might show that it's a
So
balcony. You can choose a balcony, right?
sure.
Or what
Let's
do you
see.
think?
Bedroom balconies. Yeah. So let me know the thickness of the wall. We can assume that the thickness of the wall will be similar to the thickness of this beam here. So I want just to say it will be 0.2 meters. So from here I can just click OK. So we have our beam with now the wall load. So what we'll do, we just copy and then we paste on other beam, because the wall weight will be the same across all these beams. So let me just right click on the just click on the beam, then right click, copy the beam manual. No, just copy beam manual load. No, do you have copy beam wall load? Yes, that's the, and then come to your navigation bar here, then right click on the first beam, hold shift, right click on the first beam, then go all the way to the last beam, then also click on it, then click on the last beam, then right click, and then come to paste copied beam loads, that option there, and then click OK. So all our beams now are loaded. So if we go to 3D of this, let me just check. If we just go to 3D of this design, so you can see there we have it. Now, our next step will be introducing another story on top of this. So to do that, you just go to building, set out, and then go to insert story. You only need two story levels. Click OK, say OK, and then go back to building. Click on the story that you want to copy your. Yes, and then so you first ensure that the story that you want to copy, you are building from it is the one that is on the active view or on the active window here. So you want to copy story 1, so to story 2. So we just open the story 1, then you go back to building setup, then go to generate story. I think I clicked the wrong generate story. Then you want to generate story 1 to story 2. Click on these two. Then we need walls. Do we really need walls on top? No. Beams, yes. Columns, yes. Braces. Do you have any braces here? No. Rib slab, no. Slab, yes. Slab load, yes. Slab opening, no. Model line, yes. So grid, no. So you can choose. Let me choose this one. Slab load, columns, walls, no. Beams, yes. Beams are like attached with the.
We don't need the walls, I think. Do we need the walls?
But you cannot do away the walls without doing away with the beams. So that's one thing that I've just
Okay.
noticed here.
Okay.
So you can just click like that, and then you come to story 2 plan, and then you can just delete all this. So we can delete our walls. So what you do, you just click on this column, and then you click on, you select column 1, then hold shift, select this, right click, then you want to do delete. Do you have delete beam wall load? Yes, just say okay. Yes, and then now we also come here and delete the cantilever. Oh, so what we can do, we can click on this, right click, want to just to remove this cantilever here. So actually this one will not be a cantilever, it will just be like a normal slab. Or alternatively, you can remove these loads here because there is no wall above it, and then just click update, then we have it there. I think our model up to this level, it is ready for analysis. So